Okay, good morning members. Welcome to today's lesson. Today we are going to see how we use the binomial theorem to expand such brackets. Now, I'm going to try this. You try out this one. Now, the general formula for the binomial theorem or the binomial expansions is stated like that. So now, to start now, I'm going to expand square root of this. Now, I first write this as 1 plus minus 4x, the whole power a half. Now my square root I'm going to write it as a half. Now, if I'm to compare with this and this, that my n is a half, comma, my x is represented by negative 4x. So now I'm also going to substitute that formula. So I'm having now 1 plus, now my n is a half into my x, which is now negative 4x, the whole over 1 factorial, then plus n, which is a half, into now a half minus 1 over 2 factorial, then my x is negative 4x squared, then plus other terms. Why am I stopping at x squared? Because the question told me to stop at x squared. If it was x cubed, then I would also include this term. Can you now simplify? So this would be square root, my half is under square root, 1 minus 4x equal to 1, then this one going to be negative 2, then plus, the whole of this is negative a half, so this one is 2 factorial, is a 2. So when this will be now 1 over 8, then times when I square this I get 16 x squared plus other terms. Now instead this one is giving us a negative, so when we multiply this and this will get that negative. So the whole of this square root of 1 minus 4x becomes 1 minus 2x, then minus 2x squared plus other terms. Now they are asking us to the validity. The validity just gave this term here. So you say validity. Now you say modulus of negative 4x less by 1. Now we expand this. This is negative 1 less modulus of this becomes 4x less 1. Divided through by 4. Already here we should remain with x. So divide through by 4, so I have negative 4 less x less this. If it was maybe, if this was x over 2, then the modulus would be negative 1 less x over 2 less 1. This should be x, so multiply through by this. So that would be your validity if this was x over 2. If this was x over 2. So this is just the binary. Now, you want to take evaluate root 6, but you don't see anywhere here root 6. Now this one calls for square numbers, reciprocal of square number. The first square number is 1, its reciprocal is 1. The second square number is 4, its reciprocal is a quarter. The second is 9, its reciprocal is 1 over 9. Now, when you see, you have to be careful. When I put here 1 over 4, it can't give me a 6. When I put here 1 over 9, it's that I can't get anything like 6. But when I try the reciprocal 100, the square number, I'm dealing with square number because these are square, it's a square root. If it was a cube root, you deal with cube reciprocals of cube numbers. So, because it's a square, that's why I'm dealing with square numbers. If it was a cube root, you deal with cube numbers. Now, when I say, when my x is 1 over 100, what do I have? From here, I will substitute somewhere with square root of 1 minus 4 over 100, where this x I put 100, even this side. But this x equaling to 0.01, 1 over 100. So I have 1 minus 3 into 0.01, then minus 3 into 0.01 squared. Now, whenever we are removing this, I'm going to say now this is going to be an approximate value. So, when I cross multiply, I have 100 minus 4, that's square root of the whole square root of 96 over 100. Now approximately, when you press this on the calculator, you get 0.9798. Now, I'm asking, is there a 6 in here? Now, you see that you deal with square numbers. So, you say 4 divided by this to get something. But you see that if I divide this by 16, so 96 the same as 16 times 6. What? You just get the number you want to divide by this. You will see that you will have the square number inside. So, then the square root of this will be the square root of both sides. But the square root of 16 is 4. The square root of this is not there, so I leave it like this. So here this I'm going to say. Now square root of this is the whole of that. So 4 root 6 over square root of 100 is then approximately equaling to 0.9798. Can you cross multiply now with root 6 the subject? So root 6 the subject will be now approximately cross multiply by 10. So 10 times 0.9798. Then we divide it through by the 4. This 4 here. Then you see that when I give that to the calculator, my answer will be root 6 equaling approximating 2.44. Now if I give it false, to these significant figures, now I round this one to a 5. This will be 3 significant figures. And that's how you can handle that. So you can try out this, wish you the best.